Hello, this is Robert Adams, and this is my entry for the Altair Student Global Contest October. I'm part of the Michigan Baja Racing Team. Here's one of our cars from the Michigan Baja Racing Team. It's an ATV-style off-road vehicle that is designed, built, and tested and raced by students from the University of Michigan. 95% of this car is actually built in-house in our machine shop, and that means there's a lot of lightweighting to be done so we can make the most effective and efficient parts possible. This is one of our cars at the Michigan Stadium. And here is the model that I'm going to be talking about. This is a steering mount that's attached to the vehicle's frame, and it's designed to hold a rack and pinion steering assembly. It's made out of steel sheets that are bolted together. And an interesting thing about this design is that the top and bottom faces of this design are the ones going to be lightweighted. Originally, when making this design, I realized that the sides should support basically the lightweighted portion. And these sides are made of bent steel sheets, which makes it easier to manufacture. Its initial mass is 0.141 kilograms. Now here's what it looks like for setup. So we've got a little bit of chicken scratch on the top right. That's basically how I determined the load path for a cornering load on the steering wheel, because it's at this steering mount is at an angle in relation to the bottom plane, the XY plane of the car. And it's a 1G driver cornering load with no safety factor, directed in opposite directions. This material is AISI 4130 steel, and it's for setting up the model. I applied the load, a force at either end, either hole, in opposite directions. So there's a force going towards me and a force going into the screen. That was what I believe simulated a cornering load. And there are two symmetric shape controls, both at the front side and at the bottom side. Um, there's no GIF here, but there's a bottom side to the steering mount. And each symmetric shape control has three planes that fully constrain the symmetry of the optimization and the lightweighting, so that the parts that we'll be making are very easily manufacturable and simply supported. And also, the design space is partitioned so that I left some thickness on the outsides. Now here's the results up from optimization. As you can see, it's very symmetric. Topology was in the middle of the smoothness, and I optimized for around 25-30% mass lightweighting. And here's an analysis for displacement. As you can see, these loads displace the mount slightly, but it's not that much under this load. It's mostly in the sides that are lightweighted. Now for the von Mises stress. The von Mises stress is overall pretty low, since it incorporates most of the principal stresses, which is a good sign. So the final mass of this subsystem assembly was 0.084 kilograms, which means there's a 40.4% reduction in mass. And some room for improvement is more accurate FEA simulation. For example, trying to reduce that displacement while keeping the mass the same, figuring out what structure would do that. And also lightweighting on the other steel tab portions, the portions that I talked about earlier that basically I wasn't including it as part of the design space, but could include those and then connect them together with the plates in the top and make sure that we can actually make these tabs and weld them together. Thank you, Altair, for the opportunity to submit entry to this contest. It's been a pleasure, and hope to see you in the next one. Thank you.